Welcome to the demo on how to calculate a confidence interval in Minitab. So up to this point, we've been talking about point estimates such as X bar. X bar is a point estimate for mu. This sample value X bar is our best guess at what the true population value is. We may instead want an estimate for mu, the population mean, that is a range of values. And so that's what a confidence interval does. The confidence interval gives us a range of values, some low number and some high number, inside which we're pretty sure that true population value happens to lie. For more information on the theoretical background of that, see my Chapter 8.1 video on confidence intervals. We're going to walk through a problem so that we can practice calculating confidence intervals in Minitab. As a human resource professional for your company, you're responsible for creating a plan that will decrease the number of people driving to work each day. To begin to develop a plan, you are interested in estimating the mean number of miles that employees of the company commute to work round trip. In other words, you'd like to know mu, the true number of miles that people drive to work on average. You survey the company's 5,400 employees, and you get this information back from the survey. Only 1,254 employees respond, which means you're only going to be able to have a sample statistic. But we want a range of numbers. The average from that sample came out to 4.33. How tight is the interval around the 4.33? That's really the question that a confidence interval answers for us. Before we can go to Minitab and calculate, we need to know if we get to use the z distribution or if we have to use the t distribution. There are going to be two different options in Minitab, and we have to pick the right one. The use of the t distribution is necessary in cases where we don't know the true population standard deviation. If we don't know the true population standard deviation, we're going to use the sample standard deviation, and that incorporates uncertainty into our calculation. We're already using something that we would consider our best guess at what a population value happens to be. This is our best guess at what the true standard deviation is. Since that uncertainty is being imposed in our calculation, we have to use the t distribution. The t distribution is a shorter, fatter distribution that's going to give us a higher number of standard deviations that we have to go out in our calculation to calculate our confidence interval. In other words, when we use the t distribution, we're going to get a wider confidence interval. There is a little caveat to this. We typically need to use the t distribution when sigma is unknown because that incorporates uncertainty. However, if n is really big, the t distribution and the z distribution are basically the same. So our rule for using the t distribution is if we don't have sigma, in other words, we have s instead, and n is small, then we have to use the t. Otherwise, we're allowed to use the z. So we get to use the z if we know the true standard deviation or if n is big. So those operators or and are important. If we know the true population standard deviation, we don't have the uncertainty, we get to use the z. The z will mean a smaller, tighter distribution. Or if n is big, then the t distribution and the z distribution are basically the same things, and we get to use the z distribution. Once you get out to about n equals 100, the t distribution and the z distribution only offer standard deviations that are about 0.02 standard deviations different from each other, so that's close enough for what we're trying to do. So back to our practice problem. We've got this human resource professional. They've collected this sample data from a survey. Should we use the t distribution or the z distribution to find the critical value or to calculate the confidence interval? Well, we have a sample standard deviation. So this tells us we might have to think about the t distribution. However, our sample size is quite large. Because our sample size is quite large, n is clearly significantly greater than 100, we don't have to use the t distribution, we can use the z distribution. So we'll calculate and interpret the 90% confidence interval for mu. In other words, we're calculating a range of values, some low number and some high number, inside which we're pretty darn sure, 90% sure, that the true average number of miles that people commute to work is inside that range. In Minitab, to calculate a confidence interval for a single value like we're working on now, you would go to Stat, Basic Statistics, one sample Z or one sample T, using that rule that we just talked about to determine which of the two we're going to use. Because our standard deviation is unknown, but our sample size is quite large, we're allowed to use one sample Z. When you open the dialog box for this, the drop-down will automatically be set on one or more samples each in a column. That one or more samples each in a column indicates that you have a column of numbers here, and you'd be using those numbers to calculate the confidence interval. For us, we have summarized data, so we want to change that drop-down box to summarized data to be able to enter the information. When you change that drop-down to summarized, you'll get boxes pop up that allow you to enter in the sample size, the sample mean, and the standard deviation. The other thing you need to do is to click on Options and then make sure that you have the right percent in the confidence level. For our example, we're going to change this to 90% so that we've got the proper critical value being pulled in to our confidence interval calculation. Once you enter in the 90%, you hit OK, OK, and you'll get the output. Here's the output from one sample Z. Our confidence interval is generated here for us, and we can easily interpret this. Using Minitab is so much easier than trying to calculate this thing by hand. Let's talk about what those two numbers are, how we interpret those. We always want to be able to write a sentence given the numbers that we've calculated. So for a confidence interval, you would always write something like this. We are 90% confident that the true, in this case, average number of miles that the workers commute to work is between 4.17 and 4.49. In other words, we're pretty darn sure that mu falls between 4.17 and 4.49 miles. Remember that we're sampling to generate this confidence interval. So we're getting a sample average, and we're calculating a lower bound and an upper bound on a confidence interval. We're fairly sure that that confidence interval will contain the true mean. However, there is a chance that we've calculated a sample mean like this and a confidence interval that ends up not containing the true mean. This is why we say we're 90% sure, or 95% sure, or 99% sure, depending on the level of confidence we've chosen, that the true mean is inside the interval. Thanks for watching, and I'll see you again soon.